This is the second of the definite integrals, although this integral is not your normal definite integral. It has an infinity there, which makes it improper, which means I'm going to have to use limits in one way or another to evaluate this thing. Before I do that, though, I look at it, I see x e to the negative x over 3, and I think, boom, integration by parts. So, I'm going to take the x, drive it get 1, go down to 0, and then I'm going to write the e to the negative x over 3, which is the other part. This column gets integrated. That gives me minus 3 e to the negative x over 3. And then the next one, my next integration, is going to give me minus 9, or actually, it's a positive 9 because I got a double negative there. Where's my e to the negative x over 3, like that. So, as I go down my row here, I get plus, minus, or go down my column. So what I get here is that this is equal to the limit as a approaches infinity of, open bracket, minus 3x. So that's the product of, first I'm going to do the product of these two. So I get minus 3x e to the negative x over 3. My next product is these two. So I'm going to get minus, again, 9 e to the negative x over 3, close bracket, from 0 to my a value, which is going to go to infinity. So let me get this out of the way a little bit. Actually, don't really need it anymore, so we'll get a little less clutter. So this is equal to, what I'm going to do is now plug these two values in. Maybe I'll do the a in red and the 0 in green. So for the a, I can't really plug that in, so I still need to use limit notation, and in order for this to be correct, you need to do this. Limit as a approaches infinity. Now I'm going to plug in a for all of my x's. So I get minus 3 a e to the negative a over 3 minus 9 e to the negative a over 3, close. And now I'm going to do the 0 stuff. I don't have to look at the limit for 0 because I can plug 0 into these guys. I can't plug infinity into any of these things. So, undo. Notice when I plug in 0 here, I get 3 times 0 times whatever, right? As long as that doesn't go to infinity, I'm good, right? I get, actually, take that back. I can't do that. I'm going to need to use Hopital's rule for this, but, and then this thing. This is the one that's easy. My bad. So this guy right here, the limit as, or as I plug in 0 for this, actually. Sorry, I don't know what's going on here. Anyway, I am plugging in 0. I can plug in 0 for this. I can plug in 0 for this. I don't have to look at a limit to plug in 0 to e to this, right? So maybe I'll write it out. I get minus 3 minus open bracket negative 3 times 0 times e to the 0 minus 9 e to the 0 close bracket. So that's just plugging in 0 to all of those guys. And I'm going to rewrite the red line. I'm going to get equals limit as a approaches infinity of open bracket minus 3a over e to the a over 3, and I think there might be an error potentially in the study guide solutions at this point. And then I get minus, so at this point I am going to evaluate this term by looking at the limit of that thing as a goes to infinity. So as a goes to infinity, I get e to the negative infinity, And that, I don't have to use any calculus, that's an exponential decay problem, so that thing is going to have an asymptote of 0. So this thing's going to go to 0. So I can write minus 0 for that from a calculus perspective. And then all this stuff over here, this stuff goes away because I get 3 times 0 times e to the 0. E to the 0 is 1. So this e to the 0 is 1. What I'm getting is a double negative 1, 2 on the 9. So I get plus 9. Now I need to use Hopital's rule. I'm actually going to scroll down, give myself a little bit of space. I need to use Hopital's rule to evaluate this thing right here. So in order to do that, I need to derive the top and derive the bottom. I could write hop to indicate what I'm doing. So this equals the limit as a approaches infinity. The top derives to 3 with a negative out front. And the bottom derives to 1 over 3 times e to the a over 3. And then I'm going to close bracket and then write plus 9. Now, this thing is now actually evaluatable. What happens to this thing? The bottom stays still. Sorry, the top stays still and the bottom grows exponentially, right? So I get number over a way big number, right? Number that's not changing over big. So this term right here winds up going to 0 as well. You could also think of it as kind of like a version of this, actually. And we know that that goes to 0. If I were to multiply by the reciprocal of this, I would get actually the exact same term and move this to the top, as I have here. So same logic for this thing going to 0 means that this thing goes to 0. So I get that this is equal to 0 plus 9, which means it converges to a value of 9. Scroll up if you want to see the top again. You can pause it if you want. Scroll back down. There you go.